Hello and welcome to today's lesson. Today we're going to look at the distance between points and lines. Of course, this is working on the coordinate grid. So let's start by refreshing your memory about something you once learned, and it's called the distance formula. If you have 2 points, and I'll call this first point given the x1 and x and y1 coordinates, and we'll give our second point the coordinates x2 and y2. And this is just to say whatever these coordinates are, we have 1 point and another point. How do we find the distance between these 2 points? That is a straight line distance. We had a formula that looked like this. It's actually built up from Pythagoras' theorem. And it looked like this. You find the difference between the x's, and the actual order here doesn't really matter, but usually the formula is written as x2 minus x1 all squared plus the difference between the y's, and then also all squared. So that is our old buddy, the distance formula. Now we're going to need that distance formula because what are we looking at today? Distance between points and lines. Now we're talking about shortest distances here. Let me just tell you draw a little picture here to kind of indicate what it is we're after. We're going to have a line and we're going to have a point. And what we're going to try and find is the shortest distance from this point over to that line. Now when you talk about shortest distances, you're not talking about going up to there or down to here. You're talking about straight, well, it's not exactly a perfect drawing, but straight across so that that's perpendicular. That's the kind of distance we're talking about, is what we're going to try and figure out. And in order to accomplish that, we have a distance formula, but what does the distance formula need? It needs a point and another point. And what we're going to have to do is figure out what this point is. That's kind of the first challenge. You've got to figure out what is this point, because once I have the 2 points, it's nothing to put them into the distance formula and figure out what this distance is. The distance from this point to this line. So, let's start with an example and show you specific numbers and get right to work. Okay, in this first example, our point is at 2, 5, and our line looks like this. Y equals 1/3 x plus 1. Now I chose to write this line in slope-intercept form because it makes graphing it a lot easier. But keep in mind, sometimes the line's equation is not given to us in slope-intercept form. So, for example, I could take this, and if I put it into a general form, let's say I multiply across by 3, that would get rid of the 1/3. And then I move the 3y over. So typically it would look like this. We would have subtracted the 3y. We still have the plus 3. And I chose to write the equals 0 on the right side here. We could see the equation given, let's say, or it could be presented to us in this form. Don't let that get to you. All that means is you take this equation and you rearrange it a little bit into slope-intercept form. It's a lot easier to work with slope-intercept form. Okay, so that's just to make you aware that sometimes they'll do this to you. Let's get rid of that and give ourselves a little drawing here. And then we're going to do the algebra, figure out the shortest distance. Well, picture will look something like this. We have a line here with a y-intercept of 1 and a slope of 1/3. So y-intercept is 1. And when I do the slope of 1/3, I just think of rise over run. So we have a run of 3. So 1, 2, 3, and up 1. So there's my little 1/3, my little slope triangle. So there's my line. So it looks something like that. The point here is at 2, 5, so we go 2 to the right and up 5. So 1, 2, 3, 4, 5. So that's where our point is. And what we're after is the shortest distance. I'll just do a little dotted line here. That's the guy we're after. What is that distance? So here's the procedure. So I'm going to do them in basically 3 steps here. Just give myself a little room, shorten the line. Step 1. The first thing you need is to get the equation of this perpendicular line. Okay? We have the equation of this line, that's given to us. But what's the equation of this line? So we need the equation of the perpendicular line. Okay? How do we get that? Well, it's actually quite easy, because if this line is indeed perpendicular to this line which is given to us, then their slopes have to be negative reciprocals, which means the slope of this line has to be the negative reciprocal of 1/3. So at least we know that its slope has to be negative 3. What we don't know is the y-intercept part of it. So we got half the puzzle. Now what we have to do is, well, how do we get B, the y-intercept? Well, we do know that this line here, okay, does go through the point 2, 5. So we just plug those values in for the x and for the y and solve for B. So we put in a 5 for the y, we put in a 2 for the x, and that allows us to figure out what B is. So that gives us 5 equals negative 6 plus B. So we're going to add 6 over to here. So B turns out to be 11. Now, because I am cramped for space, what I'm going to do is record what this equation is. We'll just put that on the sidelines over here. So we have our equation is y equals negative 3x plus 11. And that's for, and I'll just sort of extend this guy right here. That's for this line over there. Okay? So that's step 1. Now, I'm going to remove this and go to step 2. And step 2 is to find the intersection point of these two lines. We have a line here and we have a line here. Both equations are now known to us. We want to find the intersection point of those two lines. That's our next step, intersection point. Well, you can use a variety of ways to find the intersection points of two linear equations. But I'm going to use probably the easiest one here, and that is substitution. In other words, both of these equations are equal to y. So I'm just going to take the right side of this one and the right side of this one and make them equal to each other and then solve that equation. So in other words, I'm going to take this side here, 1/3 x plus 1, and say, well, if that equals y, then this right side of this equation has to equal the right side of this equation, which is negative 3x plus 11. And a little algebra will give us what x has to be. So I'm going to multiply through by 3 to get rid of the fractions. So I'll get rid of the 1/3. Then that will become 1 times 3. This will become negative 9x. And 3 times 11 is 33. I'll add 9x over to this side. So we have 10 x's. And we'll take 3 away, leaving us 30. So I divide by 10. X turns out to be 3. So now we have, of this intersection point, well, we have the x coordinate is 3. We need the y coordinate. And you can use either one of these two equations and substitute in an x value of 3. Now, it doesn't matter which one you use, whichever one looks easiest. Maybe I'll use the top one because then I have 1/3 times 3. Well, that's going to be 1/3 times 3 is 1. 1 plus 1 makes a y value of 2. Now, in case you don't believe me when I say you can use either equation. Let me use the other equation. So we'd be plugging in an x value of 3, okay, where the x goes here, so negative 3 times 3 plus 11. And it won't take you long to see that negative 9 plus 11 also gives you a y value of 2. So it's whichever equation looks to be the least amount of work. Well, there's step 2. And so now I have my intersection point. And now comes stage 3. Remember what we're asked to find here, and that is the distance from this point essentially to this point. Well, now that I know what the coordinates of this point are, and I have the coordinates of this point, step 3 is simply use the distance formula. Plug them in and work it out. So let's do that. It's going to look like this. So we're going to have the square root up. We're going to take the x's and subtract them, and it doesn't really matter about the order. I'm going to go 3 minus 2 squared and 2 minus 5 squared, and just simplify that. Now, what we have is 3 minus 2 is 1. 1 squared is 1. Here we have negative 3, and negative 3 squared is 9. So the answer is the square root of 10. Okay, that's all there is to that. So between a point and a line, nothing.